Hi again. This is going to be the end of chapter 12. This is section 4. This section is on similar triangles. Now, we talked about congruence already. So now we're going to get into similar stuff. We have some theorems for determining the similarity of triangles, some properties and proportions, stuff like that. So similar triangles are different from congruent in that they're not necessarily the same size. They're the same shape. They may be the same size. If they are, they happen to be congruent. So if you're congruent, you're automatically similar. But if you're similar, you're not automatically congruent. You might be, you might not be. Okay. So we write similar with a little kind of symbol there. I'm sure that has a fancy name. So we say that two triangles are similar if and only if the corresponding interior angles are congruent. Okay. And the lengths of the corresponding sides are proportional. That means that they are in the same ratio. Okay? That means that side length AB is, that the ratio of AB to DE is the same throughout. Okay? This is going to be easier seen than said. That's really awkward to have to say, so it's probably going to be easier to see. That common ratio is what's called a scale factor. Okay? So we have the side-side-side similarity for triangles. If the lengths of corresponding sides of two triangles are proportional, then the triangles are similar. Okay, so we're not saying that they're congruent, we're saying they're proportional. So if in two triangles, two sides of one triangle are proportional to their corresponding sides of the other, and the included angles are congruent, then the triangles are similar. All right. That's the side angle side similarity for triangles. So we have two different similarities, just like with congruence theorems, we have similarity theorems. Those are not as popular. Those are not as widely discussed here, but we have side, 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 and side angle side similarity ones. The most popular one that we talk about is the angle angle, or we don't have to say angle angle angle. Typically we use 3 letters, right? We don't have to use the third one because it's a triangle. So we know if 2 angles are the same, we're guaranteeing the third one is, because the sum of the angles in a triangle is always 180. So if 2 angles of one triangle are congruent, respectively, in that order, the 2 angles of a second triangle, the 2 triangles are similar. Now, look at this example. This is a good one for the scale factor and the proportion stuff, right? So look at the 3, 4, 5. Okay. Now, look at how that compares to the larger triangle. The base is 9. The hypotenuse is 15. So what is the scale factor? So these are all proportional. That means that you're multiplying the sides of that smaller triangle by the same number, that same scale factor, to get that bigger one. Well, it looks like it's 3, right? Because 3 times 3 is 9, 5 times 3 is 15. So 4 times 3 would be 12. So that missing side there would be 12. All right, let's find a pair of similar triangles. Well, do you see the 2 triangles I'm looking at here? We have BCD and ACE. We're given that AE is parallel to BD. That's going to be important, right? Parallel lines cut by a transversal. We're going to have some corresponding angles. All right, so it looks like angle C is congruent, right? Because it's a shared angle. Then that angle right there at B, and this angle down here at A, what about those, do we know? Those are corresponding angles, so we know those are the same. So we get that the triangles BCD and ACE are similar by angle angle. All right, so let's look at this one. So same directions, find a pair of similar triangles. So BD intersects AE at C. Well, we got the right angles are congruent. right? In this triangle up here and this triangle over here, the right angles are congruent. This angle right here at C are vertical angles, so we know they're congruent. So angle, angle. All right, so in this figure, let's solve for x. I said congruent, sorry about that. I meant similar. I'm glad I caught that. Sorry, similar by angle, angle, not congruent. Did I say congruent back here too? They're similar. I got congruence on the brain. Okay, so let's solve this for x. Now, if we can show that the two triangles are similar, then we can find a proportion and set up a proportion to solve for x. So are these two triangles similar? Well, yeah. I mean, I direct your attention to right there. Look at that. Look at that. Look at that. Look at that. Does it look familiar? Yeah. So these triangles are similar by angle, angle, because the vertical angles. So we know that they're similar, and we were given that it's similar, but I wanted to show you that anyway. So let's set up a proportion. So what do we know? Well, we know that 5 over this length, we don't know what it is. That ratio of 5 divided by this base length is the same as 8 divided by x. So because they're similar, we know that their sides are proportional. AB is 5, ED is 8, CD is x. So BC, this distance right here, this is 12 minus x. Because that full distance is 12. So whatever x is, whatever that distance is, we took that out from the 12, and that's what's left. Okay, so now setting up this proportion, we get 5 over 8. Now they set it up differently than I would have. I would have set it up as 5 over 12 minus x equals 8 over x, and it would have worked out the same. But that works too. So the ratio of 5 to 8 is the same as the ratio of 12 minus x to x. You solve this proportion right here by cross multiplying. So we get 5x, and then we get 8 times the quantity, 12 minus x, so you have to distribute that 8. Now, don't get these confused with equal signs. These little double arrows are just a way of saying this equation simplifies to be this equation, simplifies to be this equation. We're going to add 8 to both sides. We get 13x equals 96. Divide both sides by 13, and we get a nasty answer of 96 over 13. I liked this example because you got a nasty answer like that. So I wanted to show you guys that you didn't always have to get nice whole numbers. It is possible to get some messy fractions. So indirect measures. Similar triangles have long been used to make indirect measurements. We can determine the height of certain objects by using similar triangles. Okay? A lot of times you'll see the infamous example of a shadow at a certain time of day, your height versus your shadow at a certain time of day, and how you can then use something else's shadow to then find its height. So here we go. On a sunny day, a tall tree casts a 40-meter shadow. At the same time, that's important because at the same time of day, that angle that the sun is hitting things at is the same. And that's denoted up here. That angle is the same because it's the same time of day. At the same time of day, a meter stick held vertically casts a 2.5-meter shadow. How tall is the tree? All right, we're going to set up a proportion. So we just called that height right there x. We can set this up as x over 40 equals 1 over 2.5. I have a feeling, though, that your book is going to set this up as x over 1 equals 40 over 2.5. Called it. You think I'd remember since, I made these slides, but I've made a lot of slides, and I've spent so much time on this that I don't even remember sometimes what's on these, the details. So You set that up, you cross multiply, divide by 2.5, boom, 16. Make sure your answers are reasonable. Okay, a 16-meter tree, okay, we can believe that. Remember, a meter is about a yard, you know. If you get something like, I don't know, 16,000 meters, really, that's a lot. Don't, that tree is going up into space. So just make sure your answers seem reasonable. All right, some properties of proportions. If a line is parallel to one side of a triangle, if a line parallel to one side intersects the other sides, it divides those sides into proportional segments. Okay, so we get that parallel. So the segments that it separates it in are proportional. That's because that line is parallel to the base, we form these corresponding angles because it's, parallel lines cut by a transversal, two transversals, one on the sides of the triangle, one on the other side of the triangle. So we form a bunch of similar triangles in there. So we get those proportional sides. Similarly, we could say that if a line divides the two sides of a triangle into proportional segments, then that line's guaranteed to be parallel. Now, if parallel lines cut off congruent segments on one transversal, then they're going to cut off congruent segments on any transversal. So if the segments on this segment from A to D right here, I'm pointing as if you guys can see my finger when I'm pointing at, right there, A to D, if those segments are congruent, then these parallel lines are going to separate these segments into congruent pieces. Okay, that's great. Wonderful, right? Where am I going with this? It's a construction. We can use that property to then do a construction of separating a line segment into congruent parts. This construction is specifically for 3 congruent parts. You can do this for 4. You can do this for 5. Okay. So first thing that you're going to want to do is construct that ray up there that's going through point C, just wherever you want it. We're going to open the compass and we're going to make arcs that are the same distance apart. So we're going to start on point A, make an arc. Move the compass up to that arc that you just made, that intersection, and then make another arc. And then move the tip to that point, make another arc. Okay, so that all those arcs are equidistant. Now what we're doing is we're going to construct a bunch of parallel lines because we just segmented off that into 3 congruent parts, right? Now we can't do that with just AB because we don't know how much to open our compass. With this one, it doesn't matter how much our compass is open. We have 3 congruent pieces. We connect that third arc up there with the end point. Now we're going to have to start up here at A3, same compass setting, and you're going to come down and make an arc. Move your point to A2, make an arc. Move your point to A1, make an arc. Okay? So those are what in class I would call the down arcs, right? So you've got the right arcs, you're going up that line to the right, and then from the right arcs, you're going to make the down arcs. Then you have to make the left arcs. Then you got to come over here, put your compass there, make that arc, here, that arc. So you're going that to the left. So you got to make the right arcs, the down arcs, and then the left arcs. It's a hot mess. Okay, it just is. So of course, I'm going to link to the videos for you. The mid segments of a triangle, don't worry about that. There's the video construction to separate it into 3 congruent parts. We could do this for 4 or 5 or 6, whatever. If you understand the construction for 3, then the construction for 4 is not going to be all that bad. So you're going to have to just do the up arcs going up the line, the down arcs, and then the left arcs. So get out of this. Now, fortunately, that finishes up chapter 12 for us. So you know what that means, right? That means we are all done with constructions. So if the constructions have been kind of challenging for you throughout this chapter, you are almost done. I know in previous classes, students kind of struggle with the construction, so I can imagine that it's going to be the same for you guys, if not worse, just because of the online setting, but you never know. So, okay, that finishes up section 12.4. So, bye.